Hello students, let us jump into the topic right away. Sun rays and Earth's surface. Sun rays and Earth's surface. Even the rays that reach the ground do not heat the Earth's surface uniformly. This is because of the curved nature of Earth's surface. Compare the two pictures given here to understand. You can see from the pictures that due to the curvature of the Earth's surface, the same amount of solar energy falls on a smaller area on equator and on a larger area as we move north or south of it. Thus, it will get warmer on the equator than near the poles. You can see that while the sun rays fall at 90 degrees on the equator, they fall slantly towards the poles. This is called the angle of incidence, or the angle at which the rays fall on Earth's surface. See the chart below to understand what difference the angle of incidence makes for the amount of energy received on the surface. I hope the textbook is in front of you, and please notice the given table. At 45 degrees in northern Japan, the earth received insolation, which is the sun rays, incoming energy of the sun, which is 75 units, and whereas at 66 degree at polar circle it only received 50 units of insolation. So this is because of angle of incidence. Thus I will just draw it. Same diagram is also given in the textbook as well. Imagine this is our earth, and we have the sun over here. Imagine this is a half part of the sun, and let's take one ray of sunlight. At this specific degree, it is receiving a large amount of heat, which is solar radiation. Whereas if you imagine the heat over here, the insolation is decreased because of the angle of incidence. This angle is known as angle of incidence. So these variations occur day to day. We can't say that entire Earth surface is receiving a uniform amount of heat. It is not, because of the angle of incidence. Even though more intense sun rays fall on equatorial region, it's usually cloudy thereafter midday, and less sun rays fall on the ground. Hence, equatorial regions are not warm as the regions immediately north or south of them. So, if you notice, as we know, the earth is tilted a little bit, so that is why I have mentioned equator in such an angle. So, when the sun gives out its energy, the equator region will be having a large amount of solar radiation, or during the midday and elsewhere also. But this is not all. This is not all. As the earth goes around the sun in a course of the year, the angles of incidence constantly change. This causes angle of incidence increases in the north during the months of November, December, and decreases in the month of May, June. So, if you take this as North Pole and this as South Pole, as we all know, Earth rotates around the sun, and the angle of incidence also changes. So, when this area is receiving a large amount of heat during the months of, the angle of incidence increases in the north during the months of November, December, and decreases in the months of May and June, July. So, we shall look into a picture where I will be uploading soon, And in this picture you can notice the angle of incidence is focused differently on different part of the year. Land and water constants. So the temperature distribution over the land and oceans are quite different and varying. This will be very clear if we measure the temperature of different places or different continents and oceans. Land is considered as a good conductor of heat, whereas water bodies are different. While land gets heated and cooled quickly, oceans will take time to heat and cold. In a map, page number 22, you can see that the regions marked in brown receive maximum heat, while the regions shaded with blue gets least. So in this paragraph we are actually seeing how land and water plays a very crucial role in the temperature deviations. So here the mantra is that land actually heats up quickly and cools down quickly, whereas the water takes time to cool and heat down. That is because, let us take this as the land and this area as water. So when angle of incidence comes by, when the sun rays falls on this area, this is actually transparent. So the water would gradually go into the entire area, and it takes time for the water to get heated up because the molecules are much more separated and it takes time. Whereas this is not transparent, and when the sun rays falls on the land, it gradually heats up quickly. That is one of the reason why land and water heats down and cools down at different speed. So when a land is heated up quickly, we already discussed about this in the 7th class as well. When the temperature increases, the pressure decreases, the atmospheric pressure decreases, because the area, let's imagine this area gets heated up and the molecule starts to rise up, and as quick as this happens, the cool air starts to come and take that place. So imagine where there is a water body beside it, where this water takes times to cool down. So imagine this has a cool temperature, whereas this has a hot temperature. The winds starts to come this side because of the atmospheric pressures. So that's how complicated and complex land water deviations are. Use your consciousness and curiosity. Just go ahead and see what are the places which have this kind of temperatures and this kind of variations. Those are coastal plains. In coastal plains you can notice this kind of variations. It's always windy there, the temperatures are always constant. This will be the characteristics near the coastal areas. Heating of the atmosphere. You may be surprised to know that the atmosphere or the air around us is not heated directly by the rays of the sun. In fact, it actually allows the rays to pass through without being heated by them. The sun rays first heat the earth's surface, then in turn begins to radiate heat, which heats up the air around us. That is why it is warmer near the surface of the earth compared to the places of higher altitudes of the atmosphere. So let us discuss how atmosphere gets hot. It's because, as we discussed earlier, when land heats up very quickly, it radiates heats, and because of the conductivity of the atmosphere also gets hot. So imagine, as we are going higher into the atmosphere, what happens to the temperature? exactly, the temperature decreases as we go higher in altitude, because the radiation of that land and atmosphere decreases. So I hope you guys have understood about the relationship between land and water, at the same time what is angle of incidence. So that's all for this video. I hope you guys are curious to know about heat balance and how increases and decreases in a specific area. In the next class we shall discuss about heat balance. Keep being curious and have a nice day.